All right, this is our Algebra 2 exponential functions, lesson number 7, mindful manipulation of percents, homework review part 2. And if you have not watched part 1 yet, please make sure you give it a shot. Take a look at some of the notes there that we'll be using for this part and the ones following afterwards. So, number 4, a population of llamas are growing at a constant yearly rate of 6%. At what rate is the llama population growing per month? Assume all months are equally sized and there are 12 of these per year, round to nearest tenth percent. We had mentioned before that we're using the formula 1 plus k is equal to 1 plus r raised to the n power. And in this situation, the annual rate will be the k value, which is going to be 6%. It's the same as 0.06. The n value will be 12 because there are 12 months in the year, and our r value is what we're looking for. So when we set this up, we have in this case 1 plus 0.06 equals 1 plus r raised to the 12th power. We again use our method of raising both sides to the reciprocal of the exponent for the base, that being 1/12, because reciprocal of 12 is 1 over 12. We will then use a graphing calculator, and we'll take 1.0, I believe it was 6. 1.06, is that correct? Yes, it was. Okay, sorry about that, ladies and gentlemen. And we're going to raise this to the 1/12th power, so 1 divided by 12. So we're going to get, in this case, the value of 1.0048675551. I like writing everything out, though. Okay, so let's go back to our question here. And so we'll put in the value of 1.004867551, and there are probably some more numbers afterwards, is equal to 1 plus r. By subtracting 1 from both sides, we get r is equal to 0.0048675551, so on and so forth. And we change the percent, which means the decimal slide to write 2, which is the same as multiplying by 100. And so here, the nearest 10%, we're going to look at the 8 and see we're going to round up by 1. So we see in this case, our R value, our monthly rate, would be the same as 0.5%. So 0.5% of increase per month for the llamas. Again, the idea is that their population is growing on top of itself, so it's compounding and compounding. So it's almost like the growth is taking percent of the growth. So this is why we can't really divide by 12. Instead, we're figuring out in this case how it's growing every single month and compounding for the year. Number 5. Shauna is trying to increase the number of calories she burns by 5% per day. By what percent is she trying to increase per week? Round to nearest 10%. So here, in this case, the R value will be 5%. And that's because in this case, the K value will be the total after a week. So 5% is the same thing as 0.05. And our N value will be 7 for the 7 days. And K, of course, will be the unknown value. Let's take all this here, move it over a little bit to the side so we have some room for the work of the problem. And our equation will be 1 plus k equals 1 plus 0.05, that's the 0.05, raised to the 7th power. So again, we use a graphing calculator. We'll take parenthesis 1 plus 0.05, the 5%, and raise that to the power of 7 for 7 days. And we will get, in this case, the value of 1.407100423. Okay? So by the end of the week, 1 plus k is equal to 1.407. That seems like quite a bit. 100423. I will double check to make sure. Sometimes numbers seem. Just want to make sure. No, that looks right. 1.05. That looks okay. And so we subtract 1 from both sides. Just gotta make sure. Always try to make sure you set up things. If things don't look exactly what you think they should be, you definitely want to check here. All right. And so we multiply by 100%. So decimal slide by 2. And we see in this case, we're going to look at the next number over is 1, and we're not adding 1, so our K value, the percent increase by the end of the week, will be 40.7%. So that's by how much she wants to increase her calorie burn. If she tries to burn 5% each day, okay? Number 6, if a bank account doubles in size every 5 years, then by what percent does it grow after only 3 years? Round to nearest percent. And the hint for number 6 is, first write expression that will calculate its growth rate after a single year. So if we know the value, in this case, is after 5 years, okay, that's going to double after 5 years. We want to find out what the growth for 3 years. And the hint is very important. Find out the rate after each single year, after 1 year, and then we'll raise it to 3 years. So we begin with the 1 plus k equals parenthesis 1 plus r raised to n power. Our n value is 5 years. Now, the k value, if you're doubling, 1 plus 1 equals 2. So in this case, k equals 1. The idea of you doubled is you increase by the same amount. Right? And our r value will be the unknown value here. So we're going to have 1 plus 1 is equal to 1 plus r, all raised to the 5th power. So we're going to find r, the annual rate, but then we'll figure out what happens after 3 years. So we're going to raise both sides, okay? Now, of course, the left side would be 2 equals 1 plus r raised to n power, raised to 5th power. And we raise both sides again to the reciprocal of the exponent for the base. Reciprocal 5 is 1/5. So we're going to take our calculator and take 2 to the 1/5 power and see how much that will be. Oops, here we go. So we take 2 raised to the 1/5 power, 1 divided by 5. And we're going to get, in this case, 1.1486, 1.148698355. Okay. So we go back here. So we find out in this case that 1.86, so 2 to the 1/5 power is, 1.14, about 1.1486. 1.148698355. And some more numbers probably, equals 1 plus r. And so we subtract 1 on both sides. And so r is equal to this value of 0.148698355, and so on and so forth. Now you're probably wondering, what, should I round off now? Well, here's the thing. I'm going to leave it this amount. I have this number in my graphing calculator because this is my r value, and the question is asking for 3 years. So what I want to figure out is the effect after 3 years. Okay, so now we're finding a new k value. So here we go. It'll be 1 plus k. Again, this is a very separate k, is equal to this parenthesis 1 plus r raised to the 3rd power. And the r value is the same r from here. Now you're saying, okay, well, what would that be? Okay, well, let's see. Let's take this. Let me just undo this here. So it would kind of look like this. So 1 plus k is equal to 1.148698355 raised to the third power. And you're saying, oh, do we type it over again? No, let's go to a graphing calculator, and we see in this case we have this number here. This 1.14, so the whole thing. So we're going to take our answer, all right, I can just kind of highlight it, enter, and we're going to raise it to the third power. And we get this answer of 1.515716567. Okay, and so here, this new k value, which is going to be the percent after 3 years, okay, originally the k value was double, so, but here, after 3 years, we get 1 plus k is equal to 1.515716567, subtracting 1 from both sides. So this growth after 3 years, not after 1 year, not after 5 years, but after 3 years, will be 0.51571657. We want to change percent, so the decimal slide over by 2. And we see in this case, we have to look at the 7 here, and we notice that we're going to round up by 1. So we will say after 5 years, so after 3 years actually, after 3 years, okay, the amount grows, or increases by 51.6%. Oops, not 516, don't forget that decimal here. 51.6%. And again, we write this down, ladies and gentlemen, because we're looking for, we know it doubles in 5 years. Oops. We know it doubles in 5 years. And so the idea here is that we want to figure out what happens in 3. Okay, let me make this full page. So you have to first figure out what the annual rate is. Our annual rate was about, I would say, almost 14.9%. It's a really good increase in rate. Okay, especially if you double in 5 years, it takes a very short time, so the rate must be pretty decent every year. But we want to figure out what the effect is after 3 years, and so we use that rate of before of the about 14.9%, and we increase it, raise it, added 1, raise to the third power, and we find an increase of 51.6%. Now, if you round it up first, you might get a slightly different answer. So, but we have all the information in our graphing calculator. Why do we need to round off anyway? Okay. And ladies and gentlemen, this will be the end of our part 2 of our homework review for our exponential functions lesson 7, mindful manipulations of percents. And I hope this was helpful. If you have any questions or comments, please leave them in the comment section below, and please give us a like if you found this video helpful. Really appreciate it. And subscribe to the channel if you haven't done so already. Turn on notifications to be alerted when new videos are added. And anyway, ladies and gentlemen, look forward to seeing you in part 3. Take care and be safe.